Thank you, Tony. Thanks for the introduction, and thanks for the people who are virtually connected with us. So it's my pleasure as moderator of this session about space application. So I will be very strict on timing to allowing the next session to be prepared enough, and because we deserve to give the same respect we had in the getting the session. So here I have with me fantastic panelists, and we are going to talk about space application. So basically, Nanoracks is a service provider to ACCESS.SPACE for single payload or for CubeSat, microsat deployment into orbit. And we see fantastic idea. And the fantastic idea, they came from a special technology that can do something instead of something else. And here I have with me a representative of different type of company and different affiliation. So we have among industrial capability also Catapult, that is a sort of a space catalyst for making space closer to the life of everyone. And we are going to see what they can propose, what kind of, let's say, key problem they can solve to meet the demands request. So the section is structured in this way. I will introduce one by one the panelists just before their 5 minutes talk, and I will be very severe as a timekeeper to move to the next. And I kindly invite the audience to write in the Q&A or potentially in the chat for their question, because after the single individual talk of these fantastic panelists with us today, we are going to have a discussion. Something is stimulated by me as a moderator, but we'll be more than happy to reply to the Q&A routine session. So as first panelist here in the list, we have Bryan. Is the CEO of Dragonfly Aerospace. Is connected, as my understanding, and we ask him to confirm that you are from South Africa. I don't know if you are working remotely somewhere else, because we are living this fantastic time of the smart working, so globally working around the clock, I would say, and around the globe. So Bryan, before being the CEO of Dragonfly, he has working at the European Space Agency in the team developing the ExoMars rover. So Bryan, please, can you introduce your core business and focus on the key problem that your solution is going to solve? The floor is yours. Feel free to share a slide if you want, and go. Thank you.
Hi, Veronica. Yeah, thank you very much. Yeah, I'm going to share a couple of slides, but go through them very quickly. Let me see if that is going. Can you see the slides? Just confirm. Okay, great. Yeah, so Dragonfly is a satellite imaging technology company. You know, we are based in South Africa. I'm sitting in South Africa right now. I'm in Cape Town. You know, our core capability, as I think I said, is satellite imaging technology. At the moment, our focus is on optical payloads. Obviously, the manufacturing of those and environmental testing of those is our core focus at the moment before delivering them to customers. But long-term, looking at radar technology and satellite bus technology as well to provide a complete solution in satellite imaging. We've got two sites at the moment. We're in South Africa and Ukraine. So in South Africa, we as a main facility where we build the images and in the future we'll build the satellites. And then in Ukraine, we have we build our optics there as well as some of the electronics for our systems. Yes, our teams, we've got an experienced team working from many satellites in the past, our previous companies, and now brought together under the Dragonfly banner. And then looking at our payloads, you know, our payloads are, we're focusing on a few application areas. You know, one of the important ones for us, well, the four that we're looking at is deep space, hyperspectral, agricultural, and very high resolution. So in the deep space area, we've got cameras soon heading to the moon and to asteroids, and then in the future, hopefully Mars and other planets. And the key thing about our technology is that it enables cost-effective exploration and scientific discovery. And then we've got a big development in hyperspectral imaging. We've got 2 hyperspectral payloads launching this year. And these instruments are used for characterizing and monitoring the Earth with fine spectral resolution, which is, helps better understand and protect the environment and, reestablish biodiversity. That's a fundamental for a balanced ecosystem. So that's a big drive for hyperspectral. The other application, agricultural, we're focusing on building instruments dedicated to monitoring of agricultural land. This is obviously to optimize yield of farm yield for global food security, while at the same time, limiting the negative effects of monoculture. And then on the very high resolution side, with our imaging technology, we're planning for large constellations of microsatellites that can provide daily updates of the urban world and the highest possible resolution. So, at the moment we're at 0.7, but we're aiming for higher than that as well. The application here is tracking human activity and, providing unprecedented business intelligence. So yeah, those are the applications we're focused on.
Wow, fantastic, very nice. And there is a big portfolio of device, I would say, from TRL1 up to TRL9. So you have a very good mission in front of you. Now, the next panelist is Lucy Edge. She's Chief Operating Officer from Satellite Application Catapult, based in the UK. And she has a background in physics engineering. She has been involved in the setting up of the Disruptive Innovation for Space Center, so something very serious here. A number of other appointment member of different UK society for pushing the exploitation, I would say, of space technology and the space environment as well. So, Lucy, can you please share with us and everyone is online what is the role of Catapult in the field of space application? You are more listening to the company needs or more listen to the end user needs? And the floor is yours. Thank you.
Thanks, Veronica. That's a really good question to ask in the introduction. Are we more interested in the companies in the space sector, or are we more interested in the companies that are the end users, or the people that are the end users? The answer, of course, is both. We care deeply about making both work. I don't know whether I've lost you.
Hello, can you hear?
I can hear both of you.
Okay, so Lucy, please go ahead.
Okay, sorry about that. I don't know whether that was at my end. Yeah, we care deeply about both ends of that question, Veronica. As you said, I work at the Satellite Applications Catapult. We're one of a network of 9 catapults. They were created in the UK a number of years ago, specifically to help economic growth in key areas, and space was quite rightly seen to be one of those key areas. And the last slide was really helpful, actually, because the role of a catapult is to help really good R&D ideas become great businesses. And of course, that really means going up through that technology readiness level. And people who go on that journey will know that there are some very difficult phases in the middle of that evolution of a product. And at the Catapult, we're focused on really trying to help organizations and ideas progress through that. And that can be from a technology concept, a component, an idea or a system or a combination of components. All of these are possible. But also, I mean, we're here on an applications panel today, and an enormous amount of what we do is about stimulating the markets. You know, we want space technology to be understood by and used by everybody without a second thought. I guess much like we've seen with the digital revolution, space will stop being for geeks and for experts like ourselves, and will become core infrastructure in everybody's lives. And it won't matter if we're a farmer or a local authority, an education establishment, an energy provider, all of those businesses and sectors and anything else that I haven't mentioned will all be using space technology as background infrastructure to make it possible to do what they're doing better. And that might be better for the climate. It might be better for individuals. It might just be a lower cost solution or a more ubiquitous solution. And so at the Catapult, we try to work to help innovators make that happen. And we use a bit of a tagline. We use 3 different areas of support, as we call it. So the first one is empowering the technology. So looking at those solutions, those products and services that might be at lower technology readiness levels and really need to be developed up so that they can be a real valuable economic product. Enabling businesses is the second sort of strategic area where we focus. And that can be businesses in the sector. So helping high growth companies develop through and really mature and stabilize. But it can be businesses that are leading the movement towards using space technology more effectively. So often we work, for example, in the healthcare sector. We have a healthy living lab in Westcott in Buckinghamshire, where we help health businesses that really want to use technology early on this journey and help them embed that into their solutions. But probably the most specific and relevant to this panel of our sort of key levers is energizing the markets. So really helping to stimulate the demand pull for satellite and space-based products and services in the non-space sectors. And when I think about this, the way I try and describe this is, the way that we use location information in our lives now. It's consistent in everything we do, whether we're going out for a run, booking a taxi, ordering a pizza, going sailing at the weekend. Whatever we're doing, location information from space is there in the background of what we're doing, even if we're posting pictures of our weekend on social media. Now, when we really have people using space technology effectively and consistently throughout everything they do in all sectors, that same model will be applicable for, say, space imagery or ubiquitous connectivity, where we use space communications alongside terrestrial communications. We use images from space alongside images from other sources to really help us develop what it is that we're trying to find out. So when we get to that point, when we get to the point where space technology of all kinds is as ubiquitous and as prevalent in business ideas from all different sectors, regardless of their background and their experience. And I think we've really got that application process happening in a way that's going to make more of a difference than it is at the moment. I'll stop there, but there's a lot we can talk about on space applications.
Sure, thank you. We have still half of the panel to present their talk, but then there is enough time for the discussion. I'm pretty sure you will meet your desire later. So the next one is Guido Parissenti, and he's the CEO of JIP, Advanced Project. So it's quite curious. This JIP is for general purpose. It is Guido Parissenti. Because it's quite peculiar what he's going to present, a very teeny picosat, and so it's nice to hear. I will deserve later a tricky question for you, to be honest. So now let's go on and let's introduce your technology, focusing on the type of problem you are solving for end user. Thank you.
Thank you, Veronica. First of all, I have a partner which is called Primo, so this is the name of the of the P. Okay, so can you see my presentation? Okay, perfect. So thank you everybody to participating in this session of ACCESS.SPACE. And what I'm presenting today is our approach of our company with respect to space-enabled IoT application. So as introduced in the previous session, the number of IoT devices around the world is expected to have a tremendous increase. But most of them are suffering from lack of the connectivity, especially in the most isolated rural and unpopulated areas, where the lack of actionable data is needed and to manage limited resources. So current satellite IoT solutions are not really meant to be used by everybody. Because they rely on costly infrastructure or proprietary modems, or both, which in turn they lead to a startup cost for application for the installation of the nodes or subscription fees, which may or are still unaffordable for many, especially in the third world countries. So our approach to solve the problem is twofold. On one side, we studied the part of the infrastructure and we developed a 03U platform, which is able to relay IoT data. On the other side, and the modem side, we studied the link budget and the frequency to allow users to build their own modem, which cheap off-the-shelf components, okay, like you buy on AliExpress, for example, if you want. And with a single 3U launch, we are able to deploy 9 satellites, which alone they are able to provide on average a maximum of 1 hour revisit time on the equator. But obviously our plans are to launch more than 9 satellites. So this is not just a plan, this is already a reality. We launched more than 1 month ago our first demonstrator, and in 2 months we are going to launch the second one. And we expect to be commercially operative by 2022. So as I said, our application that we are targeting are not expected to be in crowded areas. I mean, we have a question in the previous panel related to the competition of the 5G. I mean, if you have the 5G, you do not need satellite connectivity unless you want a backup. But in remote areas, for example, for agriculture, water management, but also for critical infrastructure like pipeline of oil monitoring, the use of satellite and the use of this, but also other constellation is needed, basically. So in turn, with respect to the point of view of the application, by allowing people to have their own, let's say, device to transmit it to our constellation, or to buy if they want a model from manufacturer, and a space infrastructure on our side, which is less costly to launch and to maintain, I think we can really offer a service, a cheap service for latency tolerant application, and also for third countries. And we believe that the data generated in these remote areas allows a better resource management, helping also to address the UN Sustainable Development Goals. So thank you very much. I think I'm dying time.
Yeah, excellent. Thank you very much. Even 1 minute less. So great. So the next panelist is Miguel Cion Cardoso. He is the CEO of XONA System. I'm very curious if you can share with us why the name of the company XONA. Very interesting. So Miguel is taking care of the business development, as every CEO needs to look for customer. And please share with us your technology. What is your plan for the future, and which kind of space application you propose? Thank you.
Sure. Can you see my screen? Great. So good morning and good afternoon, everyone. Miguel Cardoso, European Operations Lead at XONA Space Systems, and essentially what we are doing is building up a new global navigation system, but directed for the age of autonomy. So really our mission here is to provide global services with the accuracy and security and resilience needed to enable things like modern technology to operate in any safe environments. So that includes things like autonomous vehicles, drones, in the maritime space as well. So if we take a step back and look at where GNSS is today, something like GPS. It's a marvelous innovation. It's now ubiquitous, with the invisible infrastructure, but it's not really designed to meet the needs of intelligent systems, and it's going to be a bit more challenging for smart systems to keep pace with, or for GPS to keep pace with intelligent systems. So what we decided to do is to address some of the problems that GPS has today, or GNSS in global, which is that, for smart applications, its accuracy, it's, about, 1 to 2 meters. The signal is quite weak and can be interrupted either intentionally or unintentionally by pretty, available and cheap jammers. And of course, it's an open signal, right? Which is quite weak by the time it gets to us here on Earth. So, even just interruptions from foliage or underpassings can disrupt the signal. So what we're trying to do is to look at the approach from a different angle. So you do have companies that are set up to be augmentation systems that provide the better PNT signals, but because of this new access to space and the cost effectiveness of actually getting satellites up there and actually having much smaller sats, we're able to launch our own constellation. And that constellation would be about 300 satellites operating in low Earth orbit. And with this new satellite, we're able to provide much stronger signal, about 100 times stronger than what GPS provides today. We are adding the layer of encryption and authentication so that signals are protected. And the signals are going to be just a lot more resilient to what your standard GNSS provides today. So, the reason I mentioned this on this before, the reason that we're able to do this is because, one, the cost of getting satellites is a lot more favorable. You can just get off-the-shelf components compared to your typical satellites that cost hundreds of millions of dollars to build. Now it's more accessible for smaller companies. The fact that we can actually get to space in a much faster and cheaper way, thanks to the likes of your reusable rocket companies, makes this access even better and starts to make this economic picture look a bit more viable. And so where we're looking at today is looking to provide those satellites in orbit, but then also partner up with local receiver companies. While our team is our experts in building payloads, there are a number of companies that have been building receivers back here on Earth for many years. So having a partnership with them makes well to integrate our signals. So in terms of the applications that this covers, like I said before, it could be anything from the autonomous vehicles to your agriculture. At first and earliest stage, it could be critical infrastructure. And like Lucy mentioned, it can be anything from ordering your pizzas via drone, or even your mobile handsets or smartwatches. So these, our signals will be able to, work with all these devices. And that actually really opens up a new world of resilient signals, and it would be quite interesting to see how this develops in the next few years. In terms of where we are on our timeline, we are looking to launch our first batch of satellites in 2024, which would cover mid-latitudes and essentially act as an augmentation service. And then from 2025, provide that augmentation service, but globally. And then at the stage where we have our 300 satellites, we'd be able to have, about a few 6 to 7 satellites in view, and be able to provide that centimeter precision, the full suite of resilient signals as well. In terms of where we are now, we are getting ready for a ground demonstration later this summer, and then have plans to launch our first demo satellites actually in orbit of Q1 2022. And so, if we've, have, an excellent team of folks from the space industries, and our CTO himself has actually come from the world of autonomous vehicles, which has quite a bit of experience in understanding how the challenges in GNSS and how that's how we can apply some of our technology into making that a much safer realm for vehicles to operate in. So we are located in San Francisco. I myself am in London, and our Canadian presence is also where our CTO is based. But we figured that, yes, if we are going to be a global GNSS company, then also this makes sense to have a global presence as well, and to touch on the space ecosystem that's also available here in Europe.
Okay, so thank you very much, Miguel. Just in time, a wonderful presentation. So we presented here the full landscape, I would say, the Earth observation capability, navigation, telecommunication. So we have a couple of questions in the Q&A. So particularly one, I think, is directed to Miguel, and it is how easy to get another system added to the popular mobile phone chipset. So basically, for using your navigation system, do we need to augment the mobile phone chip to get the signal, or how we can work? There is also a second question for you. What is your funding status? Because you have a really ambitious plan to put in orbit around 300 satellites within 6 years. So it's quite good. And how you are going to secure the use and the access of the frequency and related spectrum. Very good. So please, if you can make the point to these two questions, we may start. And then let's go on.
Sure. So the first question was basically on integrating our signals into, I guess, mobile phones. Well, there are a number of chip manufacturing companies, and the idea, like I said, was to partner with them. Essentially, the goal is to have these work long term in your mobile phones and smartwatches. But for the short term, we're looking at I guess a bit more larger devices that work within, say, the maritime community, or the likes of the critical infrastructure, let's say in power substations, telecoms as well. But that there is the long-term goal of actually being able to focus a bit more on the smaller applications. In terms of the funding stage, we did receive a pre-seed round early last year. We've been lucky to get involved in a few government contracts that's also been able to keep the wheels going. We are looking to raise some more money at some time this year, but right now we are looking at developing it would be a seed round that we're looking at. If there's any information or anything that you'd like to ask specifically on that, then feel free to shoot me an email, and we can have a discussion about that as well. And then on the I think there's a last question on the frequency side. Is that correct? Veronica, I think you're muted.
Yeah, if you kindly can keep the screen free, because you release your last slide. Okay, thank you very much. Excellent. So what about the frequency? I mean,
well, the frequency, that's something that I would have to leave to our technical guys to have a conversation with you about that. So if you want to, feel free to reach out to me and we can hop on a call on that side.
Okay, then we have, thank you very much. We have a question from the audience for Dragonfly. What is the effect of the investment? I mean, how is your scheme? So can you please share about the Dragonfly securing funding and financing as well?
Yeah, thanks. Yeah, I mean, it's a great step for our company. We now have, a stable financial backing, which we can use for a number of different things. One of the uses of it is obviously upgrading our facilities. We're working on a large facility in Stellenbosch, which will be able to integrate, up to 48 satellites per year in the sort of 100 kilogram class. So that's a big step for us. And then also, the R&D of products and getting our products faster to the market. We've got a number of products that are being sold already today, but as you saw in that chart, some of them are still in the TRL 5, TRL 7 sort of steps. So, accelerating those through to TRL 8, and then hopefully putting them in space to get TRL 9. So yeah, that's the big step there for us, and also expanding into. We're looking to be an international company, so expanding into other sites in the world as well is also one of our targets.
Very good, excellent. So it seems that also investors, they are reluctant to risk. They would like to see high TRL to put more money. So it's challenging time. Very good. So I would like to address a question primarily to Lucy. Lucy, you said that you work on both sides of the market, demand and offer as well. And through your job, I mean, are you listening to unsatisfaction of the user to say, I want Earth observation, data imaging with this type of features I cannot find, and or something about navigation, or something about telecommunication? What are the key unsatisfaction points from a user demand? Thank you.
Yeah, it's good question, Veronica. What we're really finding is that space is still quite an unknown to many of the users, and actually they're less likely to come to us and say, I want a camera with this kind of resolution, or I want this kind of repeat time, or I want this type of connectivity. They're more likely to say something like, running the ambulance service in our region is too expensive, or I want to put a sign on our fish saying it's fairly caught, but I can't see my full supply chain. And actually, it's those kind of questions that we are trying to help answer. And the space industry is a part of it, but of course, it's not the only part of it. And that collaborative work across lots of different technologies is a really important part of finding the solution. One of the biggest teams we've got in the Catapult is our user-centered design team. So this is a group of design experts who talk to anyone who wants to explore and really picks out what is it that they are trying to fix, what is the problem that they are trying to solve. And then when we combine that with what we know is possible on the technology side, we can start to build solutions between the two groups. It's a bit like a dating agency in many ways, I think, bringing the two sides of the stories together, and sometimes they get on and sometimes they don't, but we're trying to find the good relationships.
You can also have the case of divorce. After happy time, Why not?
Hopefully not too often.
Okay, thank you so much. Very clear and informative as well. Guido, so basically the business model of Bryan from Dragonfly is pretty clear. They have a key technology as a payload driving the type of mission on board of the satellite. And in your case, it seems that you are proposing a new tiny satellite for IoT application. What is your plan to manage to build the satellite, to manage the constellation, to sell the services, or you are more interested in selling the teeny satellite to everyone, and maybe everyone will augment the system buying the small satellite? I don't know. It's just a crazy idea. The other crazy question, a little bit tricky, I would like to address you is the fact that nowadays price on the market is going in the range of 1 unit U. So when you launch your satellite, are you paying the same like 1 unit, even if it's smaller your satellite? So what was really the driver to have this small satellite? Because you get maybe less space, you would like to have a better price to go up, but the market is not yet mature to offer a good price per kilos, so weight parameter. So thank you.
Okay, that's a lot of questions. So going in line with your question, yes, our main business model is to deploy this constellation and to provide a service. Okay. Indeed, it came also to our mind the possibility to sell a single constellation to a single customer. I mean, with the possibility to launch 9 satellites in a single 3-unit launch. Basically, at the current rates, you can have a swarm that is going to, let's say, configure in deploying in their own orbit for a single customer. So maybe a medium-sized company can have their own private constellation if they are concerned regarding security of data. So they basically own all the tool chain. Yeah, we thought about this. There is obviously still this possibility, but I mean, we found that the old way of servicing is still more understandable at the very beginning. And but we are also open that considering the fact that our service is based on basically a payload or a telecommunication payload. We are thinking also to provide this payload to other bigger satellite if they want to host us to increase the number of satellites in space, to improve, to reduce basically the latency between the getting of the IoT data and the deployment and the delivery to our ground station, or the revisit time above the single node, the single IoT node. Regarding the question, your question regarding why this size and why it is a cost driven or a technology driven. I would say that the cost is important, okay, even if nowadays the costs are decreasing a little bit. And yes, it is difficult to find a launch for 03U CubeSat, but it is still possible. But hopefully in the next future, we are not going to have this problem anymore, because we are going to launch multiple satellites at once. So at 1, 2, 3U will be occupied by us. So that's not the point. But on the other side, and which maybe is most interesting for this topic, the topic of application, there is a topic of application also in terms of spin-in of technology to space technology. I mean, we found that there is the possibility, and we did miniaturize many of the components of a classical CubeSat into a smaller dimension. Okay, this is allowed by the fact that the technology driven by the mobile phone industry and IT business pushed toward the low dimension of component and miniaturization itself. So the space occupied by a CubeSat, a 3U CubeSat, is not fully occupied. So why don't really pack everything inside a smaller dimension and to have the possibility to still remain into a bigger size, but to put more things in it. So we made this shrinking process that allows us or to remain onto this size and to save in launch of cost, or to enlarge again but have a bigger volume inside for payload, which can be, for example, Bryan's cameras, for example. So we do not need a 3U CubeSat to have a Bryan's camera on, but it is enough 1U or 1.5, for example.
Okay, very good, interesting. So now it's very nice what you say. I mean, having something small, you can accommodate something else because the standard offer they are bigger. So it's an interesting time. So I would like to maybe propose something within this panel. What about if tomorrow, Miguel, we said, okay, you are Sotini, I am still having the opportunity to redesign the craft sites. Would you like to come on board of my navigation? And so you jointly have navigation and IoT working from the same device. Maybe technically there are a lot of things to be assessed, but maybe it could be an idea. What do you think, Miguel? Are you interested to know more about the GAP Advanced Project Technology, and can give you an hints to better position on the market your services?
Yeah, sure. Very interested in learning a bit more about that. I mean, like I said before, like our system or our service, touches on everything from, whether it's autonomous vehicles, whether it's, road infrastructure. It's more than happy to hear a little bit more about that. It's, if we can, let's say, develop a system or some kind of demonstration or so later this year, then that works. But more than happy to have that conversation.
Okay, very interesting. We have a question from the Q&A section. It's quite elaborated, but I like to rephrase in a way that is closer to us. So we see here that we have idea to have 100 of satellite in orbits, and easily people start to think about, oh my God, it's too crowded, what is going on? And maybe there is a risk for cyber attack, there is a risk for space debris, and so on. I'm pretty sure you have something in your plan. Personally, I look at this not like a problem, but like a sign that space is much closer to Earth, in a way that everyone can be scared to be in a sunny or dark night square when he's alone, but where there are other people, there is crowded, I feel more, okay, there is something else. So if I have a problem, I can ask help. So I believe that is more a sign of participation. Being participation, you take care about, first of all, of yourself. So more people are taking care of themselves, a bigger, let's say, concern for global safe environment is in place. So maybe can you say something, Guido, about how you are going to manage the potential of cyber attack from the IoT constellation and services?
Okay, so you put in place two questions related to debris and to cyber attack, if I'm not wrong. So the cyber attack is indeed a problem, and there are companies, for example, SciSec in Switzerland, that are born to address this kind of problem. Indeed, I think that cyber risks is to be proportional to the platform you're targeting. For example, If you have a platform with propulsion capability, you really need, I mean, we are still in sci-fi, but you know, I mean, there is always the possibility that someone else is gaining control of your platform. So what is going to do with this propulsion system? Okay. And obviously the risk to be able to target a specific satellite is still low, but still you have a potential capability of maneuver something in space in maneuvers that are not allowed to. So in that case, for the part of telecommands, I would say that the cybersecurity is an important risk. If you're in a company of telecommunication, which download a lot of data and you move a lot of data, voice, provide messages, also in this case, cybersecurity for intercepting of data is something that needs to be addressed. Related to IoT data, we thought, which is the interest of getting the temperature of a crop in the middle of Vietnam? So yes, maybe someone is interested in this information, but we think that the level of interest with respect to, for example, a telecommunication satellite is a little bit lower. Okay, but still we are considering the possibility to apply to external services for securing our communication. Let's consider, for example, the pipeline, the oil and gas transport with a pipeline in the middle of the desert. You may have our constellation rely on the data, but that information about the flow of oil, it's sensitive in terms that if you know that there is a drop, you have a market impact. So that case, even if you're using our constellation that you send very low amount of bytes, that information is critical. But in that case, it maybe comes out to your previous question regarding the possibility of the company to have their own private constellation, okay, so that they handle both the beginning and the end of the chain of the data for improving the security respect to cyber attacks. Regarding the debris, I think that that's the big problem. In the previous section we have hundreds of satellites in the plan of all the 5 panelists. Okay, and this topic has also been addressed. For a satellite in the size of 1U, 0.5, even 2U. Okay, I think that the only solution is the re-entry by drag augmentation. Okay. And we are moving in that direction, trying to fit in our even still small volume, but to fit this means in order to reduce from 8 years, for example, this is the current estimate duration of our satellite, to a few months, the duration in space. Obviously, for this kind of devices, for this kind of satellites, but also for bigger satellites, you cannot think to have chemical propulsion on board to do collision avoidance, and this topic has been deeply discussed by Mike in the previous session. And electric propulsion still does not allow you to have immediate response to collision, so you have to really plan in advance what you can do. But still, electric propulsion is something that can be thought to be inserted into this kind of platform.
Okay, thank you so much. So maybe, Bryan, can you add something to this conversation? I understand that you send the camera, but and usually the camera look down to Earth. Do you see that the camera can be steered to look around from the satellite to see if there is something approaching for collision, the satellite itself? Thank you.
Yeah. Look, we have investigated in the past. It is a challenging topic. Obviously, objects are traveling extremely fast, and they, for most of the time, are going to be quite far away from you and extremely small. So you're looking at quite a big satellite in order to, quite a big imager, firstly, and then a big satellite in order to be able to track objects. You know, we had thought about in the past using this kind of technology to, you know, augment the existing space tracking, not so much for avoidance, but for much improved, you know, information about objects. So, you know, at the moment we all get our TLEs from NORAD mostly to, you know, to define, you know, where all the other objects are and plan for conjunctions based on that information. But, you know, there's an error of a kilometer on that data in general. So you are looking, you know, there's a lot of possible conjunctions which are, you know, not necessarily going to happen because there's a 1 kilometer error. So if you can be mapping all the objects on orbit, which is a very challenging problem, but, you know, maybe in the future, you know, I guess it would take a large constellation of imaging satellites to actually track all the other objects. So you're adding to the problem at the same time as trying to solve it. But, you know, on the imaging satellite side, what we're trying to do really is, you know, due to physics, the aperture of the imager defines the best possible resolution that you can get. You know, there are some tricks that you can do in terms of super resolution and things like this, but primarily it's driven by the aperture. So the closer you get to the Earth, the smaller the aperture you need, and in general, the smaller the camera, smaller the satellite. So, you know, the direction that we're driving is actually to fly lower and lower and lower. Certainly talking about the electric propulsion that Guido was talking about just now. Obviously, you know, the lower we fly, you know, the cost just comes down. And so we get higher performance systems that, you know, deorbit themselves as well very rapidly once you turn off the propulsion. So, you know, that's quite a safe thing. But, you know, the situation of when we have 40,000 satellites in low Earth orbit, which is just around the corner, I guess. Yeah, dodging those other ones is going to either a highly sophisticated space air traffic control that tells us to the meter where the other objects are, so we're not worried about 1 kilometer error conjunctions. And then I guess also being able to plan in advance if you've only got electric propulsion to make correction maneuvers. But you know, the atmospheric conditions are changing the whole time, and so drag is, you know, dependent on solar activity. So you really need a whole atmosphere monitoring system as well as a spacecraft monitoring system, and then we'll be into the situation where we have a relatively accurate traffic control situation. But I mean, I know there's lots of companies focusing in this area, and there's going to be a big industry area in the future is controlling all or just providing information. In fact, if you can just provide accurate information, you know, I don't know about a unified control. That's probably unrealistic at an international level, but certainly very high quality data will enable all of the operators to look after themselves a bit better, I think.
Yeah, very good point. And you also mentioned now that start the exploitation of the very LEO that is around 200-300 kilometers. We have seen at Nanoracks many companies, primarily not only for Earth observation, but also for telecommunication application going down. This will be in line with the telecommunication needs that has a high speed for obsolescence. So you have the opportunity to change your asset in orbit frequently because it's going to be end of the life easily. And actually, yes, I share with you that one of the benefits to deploy satellite from the station that is lower than the typical 500, 600 is primarily good for matching the requirements of technology demonstration, because then you don't need to be in orbit for around a couple of years and keep tracking of your satellite, preventing any issue. So I would like, because we are approaching to the end, I would like to thank everyone here in the panelists. I would like to thank the ACCESS.SPACE network for this fantastic opportunity. Everyone address question in the Q&A, and the single, let's say, wish that I join with everyone here, and I will have no doubt that everyone do agree that space is for everyone. So let's push everyone working on this fantastic conference for making space affordable and democratized as much as can. So thank you very much, and I leave the floor to the organizer. I think Tony just appeared here.
Thank you very much to the panelists, and you're welcome to join the ACCESS.SPACE Alliance and discuss these topics more in a committee or in a panel as you wish. Please contact me if you want to approach us at the ACCESS.SPACE Alliance. We welcome you to be part of the family. Thank you very much. I'm now going to move to the next panel, the ground segment innovation, with Andy Fry being the moderator. So I will ask the new panelists to raise their hands, and thank you so much, Veronica and everybody else. Have a nice day. Please, I hope you can stay further in our conference. We have some great panels coming up.